Today we're going to be looking at what we call parametric equations, and these are used to write x and y values in terms of a third independent variable that we call t. Now this t is what we call the parameter. Now parametric equations, we tend to use these in physics quite a bit to help us better understand motion of an object, because we can separate an object moving horizontally and vertically. So let's say the path of a ball is given by the following equation. So if we were to sketch this, it would look something like this. It's parabolic in our motion. That's y. Now, the equation will at any given point give us the exact coordinates for the ball. However, in physics, sometimes we either want to know what the horizontal or the vertical components are separately. Now, we especially use this in calculus, where we want to find horizontal and vertical velocities. So we may want to find out what's the velocity in the horizontal, what's the velocity in the vertical direction. Okay? To solve these types of equations, we set up parameters to allow us to write rectangular coordinates in the system in a way in terms of an independent third variable. In most cases, we use t, and these are called parametric equations. So let's take a look at this first one right here. We want to write our parabola in terms of a parametric third variable equation. So, all very simple to do. We look at the current independent variable x. And an easy way to write this is to say let x of t equal, well, or sometimes what we say is let t equal x. So if we let t equal x, our first parametric equation is x of t, because now we're replacing in terms of t. So x's are now just our t's. And how would I write y of t now? Well, y of t would be this. Everywhere I see an x, negative 4.9 t squared plus 56t plus 7. So it really doesn't change it too much. But what happened though is now the y value is no longer in terms of x, but in terms of t, in terms of time. And x and y are now independent of each other. X and y are now independent of each other. And that's big for physics. So let's take some practice. These are pretty easy to do. Okay, let's take a look here. Find the set of parametric equations. Use the given parameter. So here they're saying let x equal t. So my first equation, x of t, is just t. What's y of t going to be? Everywhere I see an x, plug in t. 4t minus 7. There's our parametric equations. Parameters. I always see that this para, as you better get a pair of equations. So we get a pair of equations right there. Question 2. This time they're let x of t equal something else, t minus 4. Now this is important for physics, because sometimes, let's say you start 4 seconds or 4 hours later than somebody. So your time minus 4 hours. And this becomes important for us in physics when you can say you have two objects moving in the same direction, but one is just moving, one started afterwards. So you can actually use it to find out when a train or somebody might catch up with somebody else. And we'll see that later on this week as well. But going back to what we're doing today, for my y of t, everywhere we see an x, we plug in a t, or t minus 4 in this case. 3 times t minus 4. And you can leave it like this, or you can rewrite it. X of t is t minus 4. Y of t is 3t minus 12. And there's our parametric equations. So try number 3. Okay? Try number 3. Be careful when you square, okay? And then let's go into the next part, okay? All right. So, now, what we're going to talk about next is converting conic sections. Now, when we convert conic sections, we're going to use our Pythagoreans from trig. Makes it much easier for us. For example, we know that, let's start with cosine squared of x plus sine squared of x equals 1. And, of course, we have a couple of others as well, right? Don't forget we have that tangent squared of x plus 1 equals secant squared of x. And we have another one, and if you can't remember how to get them, remember sine squared plus cosine squared equals 1. If I want to get cotangent, divide everything by sine squared. Sine squared, sine squared, and that's going to give me 1 plus cotangent squared of x equals cosecant squared of x. So for these, we're going to, for anything with conic sections, we're going to use our Pythagoreans. Okay? Now, and how this works, very simply, let's take a look right here. If you notice, this is x squared plus y squared equals 1. Now, the shape of this one's pretty easy. A and B are not the same. This is going to be an ellipse. But if you notice, it's basically in the format x squared plus y squared equals 1. So if we want to write a parametric equation, here's what we can do. We can call this x is my cosines, y are my sines. So I can almost say this, cosine squared of x plus sine squared of x equals 1. Well, what are we putting in for cosine? Well, cosine squared of x equals x plus 4 over 25. And the sine squared of x, that's going to give me, well, which one does that match up with? Y squared over 4. Now, here's the difference. How we make these parametrics? Very easy. Instead of using the x in cosine squared and sine squared, this is where our parametrics come in. We're going to let this x be t. So we say cosine squared of t equals x plus 4 over, whoops, that should be squared there, sorry about that, over 25. And this is sine squared of t equals y squared over 4. By taking the square roots, here we get the cosine of t equals x plus 4 over 5. Take the square root here. The sine of t equals y over 2. And what we're going to do, solve for x, solve for y. And I'm going to go ahead and do that one right here, okay? So for the first one, if we solve it, we get x equals 5 cosine t minus 4. Solve for y, y equals 2 sine of t. And there's our parametric equations right here. And that's what we get. So let's take a look at number 5 here. Now notice, x and y, cosine squared of t plus sine squared of t equals 1. It's our Pythagorean. So what I'm going to do is I match up. The cosines here match up. So I can say cosine squared of t equals x minus 2 squared over 9. Sine, these two match up. Squared of t equals y plus 1 squared over 16. And I take the square root. Cosine t equals x minus 2 over 3. Sine of t equals y plus 1 over 4. You don't need the parentheses. And I solve. What's x going to equal? And if you want to, we can write x of t now. Multiply by the 3 cosine t, add the 2. What's y of t going to equal? Multiply by the 4 sine of t minus 1. And there's our parametric equations. Now, the only oddball ones are parabolas. Now, for a parabola, unfortunately, it's not as easy. We can't really use our trig ones because there's no sine squared because only one term is squared. So if only one term is squared, we have to just use it the other way. We get to pick a parameter. Now, when I say pick a parameter, make it easy. Ready? I look here. This x plus 2, I let that be t. Okay? So if I let x plus 2 be t, x of t then is just t minus 2. Well, how would I get y? Y of t then would be very simple. 1/4. Well, what did we just say x plus 2 was equal to? T. T squared minus 3. Very easy to do. Let's try this one. This one's a little bit different. It's a sideways parabola. There's my y minus 1, so I'm going to let y minus 1 equal t. So therefore, what's y of t going to equal? T plus 1. What's x of t going to equal then? Well, negative 1/8. Y minus 1 is our t squared plus 1. And there's our parametric equation. So if you need to retry these again, okay, they're really not that bad to do. And let's do one more. Let's try number 8. We'll set it up. A circle centered on here, radius of 6. Okay? This becomes, as a circle, x plus 3 squared plus y minus 2 squared equals, be careful, square root 36. Now, we want cosine squared of t plus sine squared of t equal to 1. It has to equal 1. Very important. So to get equal to 1, we're just going to divide everything by 36. And we get this. X plus 3 squared over 36 plus y minus 2 squared over 36 equals 1. Alright, so take a minute and convert this just like numbers 4 and 5 above and convert that to parametrics, and we'll take a look. We'll finish this one up tomorrow and then go into part 2 and we'll finish this lesson up, okay?